And here is our addition problem. Over here we have the process for adding rational numbers, and we're going to use that to sort of guide our thoughts on how we should add rational expressions. So if we look over here, they want us to add 2/3 plus 1/7. And the first thing they did is they multiplied the 2/3 by 7/7. And then they multiplied the 1/7 by 3/3. And what they're trying to do there is, in order to add two rational numbers together, the denominators have to be equal. And since 3 and 7 weren't equal, we can make them equal by timesing 3 by 7 and timesing 7 by 3. They'll both be 21. You can see that in this next step here. But you can't just multiply the bottom by whatever you want. That's going to change the fraction. But if I multiply the top and the bottom by the same thing, this is basically multiplying by the number 1, because 7/7 equals 1. And when you multiply by 1, nothing happens. So this 2/3 here, we're multiplying it by 1, and we're getting 14/21, which is an equivalent fraction. You could divide the top and bottom by 7 and go back to 2/3 and see that 14/21 is the same fraction as 2/3. And the same thing's happening with 1/7. We're timesing top and bottom by 3, which again, this is just a fancy way of writing times by 1. And timesing by 1 is not going to change this, but it is going to get it so the denominators are both 21. 14/21 plus 3/21. So you got 14 out of 21 pieces. You got 3 out of 21 pieces. You add those together, you got 17 out of 21 pieces. So let's see how that compares with the rational expressions. So we got 3 over x plus 7 plus 4 over x minus 4. Now those denominators are not the same, but in this next step, you can see what they did. They basically multiplied by 1 here and here to get the denominators the same. And so by multiplying x plus 7 by x minus 4 and multiplying x minus 4 by x plus 7, we're going to end up with the same denominator in both of these fractions. And then to keep the fractions equal to the original, I multiply the tops by those same things as well. And we're basically just multiplying by 1. So my next step here is going to look like this. We're going to have 3 times x minus 4 over x plus 7 times x minus 4. And I'm adding to that what I have over here, which is going to be 4 times x plus 7 over x minus 4 times x plus 7. And the order those are in can be switched if you want to make them look exactly the same. But we know that x plus 7 times x minus 4 is going to equal the same thing as x minus 4 times x plus 7. That's like saying 3 times 7 and 7 times 3. They're both 21, right? Now, one thing I could do here is I could distribute the 3, and that'll give me 3x minus 12. So let's go ahead and do that. And I can also distribute the 4 here and get 4x plus 28. There we go. We've distributed the tops and multiplied them together. And now, looking at the next step, we can now add the tops together, and the denominator just stays the same. So we'll have 3x minus 12 plus 4x plus 28, all divided by x plus 7 times x minus 4. So now the next step with the rational numbers was to combine them together and get 17. And over here, I'm going to combine like terms. So 3x and 4x gives me 7x, and negative 12 plus 28 gives me 16. So I did get the same answer. And so to kind of recap, our goal when adding rational expressions, just like when adding rational numbers, is to get the denominators the same by multiplying by these fancy ones, we'll call them. And then once the denominators are the same, I can just add the numerators and make a single fraction and then simplify what's there.